In the last video for today, we are going to continue with the rationalizing denominators because it gets a little bit trickier. But there is one step we have to take first. Foiling radicals. And foiling, by the way, it's not a technical term at all. It's just a sort of a shorthand way of saying multiplying two binomials together. Whenever you FOIL a binomial times another binomial, you have to distribute both terms from the first binomial. So I'm going to distribute the 3 root 5 to both terms from the second binomial, but also distribute the second term, the negative 2 root 3, to both terms in the second binomial. So I'm going to end up making 4 products here. And this is the same for any binomials, like x plus 5 times x minus 2. I do the same thing. It's called foiling for reasons that aren't really important. But as long as you remember that you're distributing both terms, you'll be in good shape. So that's what I'm going to do. I'm going to distribute everything. When I multiply 3 root 5 times root 2, remember, you can multiply a radicand times a radicand. And I can multiply 3 root 5 times root 3. I can multiply the radicand times a radicand. And now I'm finished distributing the 3 root 5, I'm now going to distribute the negative 2 root 3. Negative 2 root 3 times root 2 is negative 2 times the square root of 6. Make sure you remember you're distributing that negative along with it. And negative 2 root 3 times root 3 is negative 2 root 9, which some of you might have noticed, wait a minute, root 9, that's a perfect square. I can simplify that. And that's absolutely correct. So everything else is fully simplified. There's nothing else I can do, but I can take that root 9 and call it 3. And so I can multiply that last negative 2 times 3 to get a final answer. There's no correct order to writing these numbers, as long as you have the 4 terms correct. I do want you to notice what happened there. This is important. It was the root 3 times root 3. When they multiply together, they make a plane 3. Anytime two identical square roots multiply by each other, they make the radicand, which makes sense because the square root of 3 is the number that if you were to square it would equal 3. Well, if you square it, it should equal 3. That's what the word means. And that's going to happen in the next example too. 5 root 3 minus 6 times 5 root 3 plus 6. I want you to notice the similarity between the two. They're pretty much the same thing. They're not opposites of each other. That's important. Don't use the word opposite because they're not. But if the two terms, the two binomials, have one shared term, so the 5 root 3, they both have a 5 root 3 in it, but one pair of opposite terms, the negative 6 and root 6, these binomials are called conjugates. It's a fancy word. Let's see what happens when you multiply conjugates together. So we'll distribute. We'll do it the slow way at first. 5 root 3 has to be distributed to 5 root 3 and then to 6. And the negative 6 has to be distributed to the 5 root 3 and to the positive 6. So again, we're going to have 4 terms here. 5 root 3 times 5 root 3. We can multiply the 5 times the 5 and the root 3 times the root 3. And like we just saw in the last example, that's just going to make up whole 3. We don't need that intermediate step with that root 9 anymore, now that we know what's going to happen. And we can multiply the 5 root 3 times the 6. The coefficients can be multiplied together. The radical has nothing to multiply by. Sorry, that's positive. The next one is, now I'm going to do the negative 6 times 5 root 3. So that's going to be negative 30 root 3. And then the negative 6 and the negative 6, negative 6 and the positive 6 multiply to make negative 36. So I want you to notice what happens here. These middle terms, they cancel each other out. That is not a coincidence. That will always happen whenever you multiply two conjugates together. The middle terms will always cancel out. And what you're going to be left with, that 25 times 3, Well, it happens to be a 75, but more importantly, it is the square of 5 root 3, because that's how we got it. We squared the 5 root 3. And the minus 36 at the end? Erase that so it doesn't be confusing. 36 at the end, we get that from squaring the 6, right? That is 6 squared. So we've got the square of the first pair of terms minus the square of the second pair of terms, or 75 minus 36. Of course, we can do the subtracting here. But more importantly, I want you to note there's a name for this expression right here. It's called a difference of squares. And importantly, there are no more radicals. That's what I want you to keep in mind. When you multiply two conjugates together, what happened was there were no more radicals. That's going to be important on our next slide. Because just like before, we want to make sure there are no radicals in the denominator. So I've got a 5 plus root 3 in the denominator, and it can't stay there. But don't write this down in your notes, because spoiler alert, this is not going to work. If you were to multiply this by root 3 over root 3, which is a very good instinct to have, we've got a slight problem. In the numerator, I don't really care what happens, because I don't care if there are radicals in the numerator. I distribute that root 3 times 1, minus root 3 times root 3. Great. Okay, fine. The denominator is where I have problems, because multiplying the whole thing by root 3, remember, the 5 plus root 3 is grouped together. It's in parentheses. That's grouped. So if I'm going to multiply that by root 3, I would have to distribute the root 3, which would give me 5 root 3 plus 3. And yay, my 3 is no longer a radical. I fixed it. Except I didn't really fix anything. I just moved the problem over. That doesn't do anything. Moving the problem over doesn't actually solve the problem. So we need a new strategy. This is where what we just said about conjugates comes in. If I want to get rid of the radical, not just from the root 3, but also make sure it isn't passed along to the 5, what I need to do is multiply by something that will completely get rid of all radicals. And we saw on the last slide that if you multiply a binomial, like 5 plus root 3, times its conjugate, you'll get a difference of squares, and since they're squares, there won't be any more radicals. So that's what we're going to do, is multiply by the conjugate of the denominator. Of course, we have to do that to both the numerator and denominator. But we're going to multiply both the numerator and the denominator by the conjugate, that's the important word here, of the numerator. Sorry, of the denominator. And, well, we got to actually do the math. So in the denominator, we'll do that first because it's the easier part. We know the denominator is going to be a difference of squares. That was the whole point. Just like we saw on the last page, we had the square of 5 root 3. They squared together to make 25 root 3. And then the square of the 6 to get that second term. Well, we're going to see the same thing here. The square of the 5, right, 5 times 5, so we're going to square that, minus the square of the root 3, which is 3. Magic. No more radicals. In the denominator. In the numerator, there will be some, because foiling all that out is going to lead to some radicals still. So we're going to have to FOIL it out. That's 4 multiplications again. 1 times 5, 1 times root 3, sorry, negative root 3, negative root 3 times 5, and negative root 3 times negative root 3, those cancel out. The radicals cancel out. We're left with just 3. Also, because both of those terms were negative, that's why their product is positive. We can do a little bit of combining there. 5 plus 3 is 8. and negative root 3 minus 5 root 3. We can combine that. Remember, there is an invisible 1 there. That's why it's negative 6 root 3. And although this is really jumping the gun a little bit, using a couple of skills we haven't done in this class yet, hopefully you've learned before you can reduce fractions even if there's more than one term in the numerator like that. The way I wanted you to be thinking about it is if you can factor out a term, if you can factor out a factor that will cancel out with the 22, you can do that. Well, 8 minus 6 root 3, I can undistribute a 2, or factor out a 2 from both of those terms. And then the 2 over 22 can be reduced. Make sure you're careful. You can't just reduce 8 over 22 to 4 over 11 because the 8 is stuck in the numerator. Unless we factor out the 2, then I can reduce the 2 over 22 as 1 over 11. We will talk much more about that aspect later in the year. It's not that important right now. So if you would have left your answer like this without canceling out at this point in the year, that's okay. Soon we'll learn how to do more with it.